Section 8.1 is on adding and subtracting polynomials. So, first a few definitions. A polynomial is a monomial or the sum of monomials, and each monomial is called a term. So you'll recall from Chapter 7, a monomial is a number or a variable or the product of a number and variables. A monomial has no plus or minus in it, however a polynomial does. So when you add or you can subtract monomials, you get a polynomial. A binomial is the sum or difference of two monomials, and a trinomial is the sum or difference of three monomials. The degree of a monomial is the sum of all of the exponents of all of its variables. So just add up all of the exponents to get the degree of a monomial. Then the degree of a polynomial is the greatest degree of any term in the polynomial. So you're going to find the degree of each monomial and take the biggest one. That'll be your degree of a polynomial. Let's take a look at a couple examples here. Determine whether each expression is a polynomial. If it is, find its degree and determine the type. So the first one is 3x. Well, this is a monomial, and by definition, every monomial is also a polynomial. So yes, this is a polynomial. Its degree is 1, and that's because you can put a little 1 exponent on that x. And as I said before, this is a monomial. I think I spelled that wrong. Monomial. There we go. Okay. Number 2, -6. Well, this is also a monomial, so yes, it qualifies as a polynomial. Its degree is actually 0. It does not have an exponent, but you could put any variable, say for example an x, and raise it to the 0 degree. Remember that anything raised to the power of 0 is just a 1. So in this sense, -6 is a polynomial with a degree of 0. And since there's no plus or minus in this, this is a monomial. Number 3, x to the -3 plus y to the a. Well, this is not a polynomial, even though we have two terms being added. The x to the -3, you can't have a negative exponent, and you can't have a variable as an exponent as well. So no, because no negative exponents and no variables as exponents. Okay, so that is not a polynomial. Number 4, -6x squared plus 4x minus 2. Okay, it doesn't look like we've broken any of our rules, so yes, this is indeed a polynomial. Its degree is 2, because that's the highest power. And since there are 3 terms, one term is -6x squared, the other is 4x, the other is -2, this is a trinomial, because it has 3 terms. And number 5, 1/7 x squared y minus 1/6 x cubed y squared. Yes, this is also a polynomial, okay, even though it has fractions. The fractions are coefficients. They're not fractions as exponents, and there's no variable in the denominator, so this does qualify as a polynomial. Its degree is 5, because let's look at the first term here, 1/7 x squared y. The degree of that would be 3, because it's x squared and y to the 1. That 2 plus 1 is 3, so the degree of that term is 3. Now -1/6 x cubed y squared, the degree of this term is 5. Add up the exponents. And to find the degree of the total polynomial, take the larger one. This degree was 3, this degree was 5, so the degree of my polynomial is 5. And since there are 2 terms here, this is a binomial. Okay. Standard form of a polynomial has all of the terms arranged in order from the greatest to the least. So you're going to be looking at the biggest exponent, list that one first, and then go down to the smallest exponent. And the leading coefficient is the coefficient of the term with the greatest degree. Actually, if you rewrite the polynomial in standard form, it's going to be the first number that appears. So let's do a couple of these. Write each polynomial in standard form and identify the leading coefficient. So let's look for our biggest exponent here in number 1. So I have 8 minus 2x squared plus 4x to the 4th minus 3x. My biggest exponent is in 4x to the fourth, so I'm going to start with that one. Then my next largest exponent is in negative 2x squared, and be sure you keep that negative or that minus in front of the 2. And then I have negative 3x to the 1, or just negative 3x, and then plus 8. So that would be the polynomial written in standard form. And the degree, the leading coefficient, my leading coefficient is going to be 4, this big 4 out front. Let's take a look at number 2. Y plus 5y to the third minus 2y squared minus 7y to the sixth plus 10. Start with your largest exponent, and that's going to be negative 7y to the sixth. And then my next largest is a positive 5y to the third minus 2y squared plus y plus 10. So that's written in standard form. My leading coefficient is the number out front, and that's going to be a negative 7. Now, to add and subtract polynomials, basically all we do is combine like terms. So we're going to, in this case, find each sum or difference. So I have a trinomial here in parentheses, 5x squared minus 3x plus 4, and I'm adding to that the trinomial 6x minus 3x squared minus 3. Now when you're adding, the parentheses really don't make any difference. Okay, so I can rewrite this without the parentheses. Minus 3x squared minus 3. Now I'm just looking to combine like terms. And remember that like terms have exactly the same variables raised to exactly the same powers. And this is where I like to use some colored pencils or highlighters. So here I have a 5x squared, and here I have a negative 3x squared. Be sure you grab that negative in front of it. I also have a negative 3x and a positive 6x. And there's a positive 4 and a negative 3. So let's just combine the squared terms, the ones I've circled in pink. So 5x squared minus 3x squared is going to give me 2x squared. Don't touch the exponents, those stay the same. It's like I have 5x squareds, and I need to take away from that 3x squareds. Now let's look at the purple ones. Negative 3x plus 6x is going to give me a positive 3x, and positive 4 minus 3 is going to give me a positive 1. Okay, let's take a look at another second example here. So I have y to the fourth minus 3y plus 7, and I'm adding to that 2y cubed plus 2y minus 2y to the fourth minus 11. So again, I think I'm going to circle my like terms with the same colored pen. So there's a y to the fourth, and there's a negative 2y to the fourth. I only have one term that's raised to the third power. And let's see, I don't have any y squareds, but I do have a negative 3y. And I have a plus 2y. And then I have just some plain old numbers, a positive 7 and a negative 11. Okay, so let's combine our y to the fourth. So I have y to the fourth minus 2y to the fourth. That gives me a negative y to the fourth. Just think of it as y minus 2, or I'm sorry, 1 minus 2. And then I don't have any y cubes, so I just have a plus 2 y cubed. And then looking at the green circled terms, negative 3y plus 2y gives me a negative y. And then my red terms give me a negative 4. So there's the sum of those two polynomials. Now, subtraction is a little more complicated because it actually does matter, because I'm taking this whole first polynomial and I'm subtracting each term of the second polynomial. Okay, make sure that you subtract, and I'll write this down here. Subtract each term of the second polynomial. Often what we tend to do is think about just subtracting the first term, but in this case I have to do minus a negative 2x cubed, minus x squared, and minus a negative 2. Another way to think of this is to think of this minus as like a negative 1 that you have to distribute to each term in the second polynomial. And I kind of like doing that, so I'm going to rewrite this. My first polynomial stays the same. And now I'm going to distribute this -1 to each term of the second polynomial. So -1 times -2x cubed is going to give me a plus 2x cubed. -1 times x squared is going to give me a -x squared, and -1 times -2 gives me a plus 2. Basically what I did was I turned my subtraction problem into an addition problem. Now I just want to do as I did in the two previous examples and combine like terms. So there are my x cubes, there are my squareds, and I think I have just one term with an x, and then I have two terms that are just numbers. So that's going to give me a, whoops, go back to black. That's going to give me a 6x cubed. Looking at the purple, minus 4x squared. Yeah, that's right. Plus 6x minus 2. So I think the easiest way to deal with subtraction of polynomials is to rewrite the second polynomial and make sure that you're like distributing a -1, or write it as though you were subtracting each of those terms. And let's take a look at just one more example here. Okay, and again, I'm going to think of this as, since it's a subtraction, I'm going to think of this -1 being distributed to each term of the second polynomial. So I have 8y minus 10 plus 5y squared, and now distributing that -1 is going to give me -7 plus y cubed minus 12y. And again, let's just combine like terms. I only have 1y cubed. I only have 1y squared. That's 5y squared. And I have an 8y minus 12y gives me a -4y. And -10 minus 7 is a -17.